4th. Perfect. So now my setup is working. Let's start with today. We have a tight schedule. So the schedule is getting a little tighter because we are progressing a little bit on the slow end. So we need to keep up pace. So without further ado, let's just start. And we always start with the homework part of the assignments. And as we did not much assignments the last time, as far as my notes are correct, the only assignment that we did was the shell command, and there is the printf command assignment here as well. So in this printf command exercise, we use printf instead of echo because printf has the ability to format the output, which is not possible in echo, making it a versatile tool for generated structured data and messages. And you see here some instructions that you need to perform on your virtual machine, on your bash console. So basically there are 4 subtasks, so to say. The first one is like reading about the printf command in the manual, then printing hello world, then printing the number 100 as a floating point number, and then display 2 numbers in a sentence. For example, Tom has 5 apples and 15 oranges. So let's take a look at that. The easiest thing is to print out hello world. So just printing out hello world, the synopsis is the same as for echo, so we can use printf to print hello world. With one difference, like if we do echo hello world, you see the difference right away. Printf does not have a trailing new line character. So in order to produce the same outputs as hello world, you would add \n, this rich text which represents a new line character printing a new line on the console. And now we have a new line and the shell prompt starts at the new line. Perfect. So how can we display numbers? Well, we can just like print it, but that is not the use case that we want. We can input text as the first argument. For example, the number 100 is colon, and then we do a %f. %f is a variable in the input, in the first input to printf. And if you pass a number as a second argument to printf, the variable, the first occurrence of $f, F is for floating point, is substituted with the second argument here. Let me do a \n at the end, so we have a more nicer output here. So the number 100 is exactly this. And as you see, well, my locale is apparently German because we have a comma as digit separator. I told you about the struggle. Germans being like having a comma as digit separator and a where you have a dot as digit separator and so on and so forth. So this is apparently German notation here. The printf command is sophisticated in a way that you can like configure this %f, which is in fact floating point. Amar question in chat, this is right, yes. F means floating point. D means digit, so it's just like an integer value, but the task is to have floating point values. And if we do %.2f, then you see you can limit the number of digits after the point by 2. So if you want to have like a currency, for example, and you do want to have 2 digits after the dot, euro, yeah, then you can limit it this way. And the last task was to do 2 numbers. So in order to understand what we call positional parameters. So printf Tom has %d oranges and %d apples. I guess it's the other way around, but does not make any difference like in methodology. So you can pass to printf a string where you have multiple variables such as %d or or 2%ds in this case. And then you can pass two variables again. So in fact, this is the third variable, the third argument to printf. This is the second argument because the string is the first argument to printf. 5 is the second argument, and 15 is the third argument to printf. And what printf does is it looks at the string, and then based on the position, replaces the first variable with the first argument that came after the string, and the second variable that you find here with the second value provided as an argument on the command line. So this formats, let me do a -n again. This formats the string with %d oranges and %d apples to Tom has 5 oranges and 15 apples. So this is how the printf command works. Does anyone have a question?
I have a question.
Sure, go ahead.
In the line, I don't know the line number, but it is like the number 100 is these dots, and then print f %f, then slash. What is the meaning of slash? I didn't understand the slash only, but the other part I understood without slash. What
Okay.
slash is doing?
It's actually not just a slash, it's \n. I guess you're referring to what I highlighted in the shell here, this \n, right?
Yes.
This is a special character. It's called rich text, and this special character \n is or represents a new line.
It is like Java, like in Java also it happens.
Yeah, exactly.
Like
Exactly.
Okay, thank you.
Perfect. Okay, then if there are no further questions, we jump into...
Hello.
Hello.
I have a question. Can I ask?
Yeah, sure. Go ahead.
Yeah, thank you so much. So, as if you have uploaded so many exercise on the island, so this is mandatory to upload after solving all these, or
No.
It's a kind of assignments.
So nothing is mandatory. So in my course, I treat everyone as like as self-responsive as possible. So let me switch
these
over
are for self practice only.
Exactly. So I put on a lot of exercises, and we do, or I give some exercises or practice tasks. We mix into this into the lecture. So I give you some time, like 15 minutes, to do this. And there are like extra exercises that you can do as homework. Everything is not mandatory. So you're not obliged to do them. You're not obliged to upload any of them. So
this
I
is
basically
just for
exactly, it's just for
practice.
practice.
For the practice, so that we can just get much familiar about the Linux operating system.
Exactly.
Thank you so much, sir.
Okay, so hopefully, if you remember the last time, I was laggy a little bit. And the reason, I figured out what the reason for my lag was. And it was actually a recent kernel update in my operating system, because I use an operating system that has a very bleeding edge update strategy. So whenever like a new component of the operating system is published, then my distribution, I'm using a Fedora Linux distribution, picks up the update and distributes the updates to all like users of the Fedora Linux distribution. So this would be like being more on the bleeding edge, installing all the freshest new updates that are on the market. Has benefits and drawbacks. The benefits would be you get all the new software, get all the new feature, and you know new is always better. Yeah, but not always. There was a bug introduced in the GPU scheduling. So we talked about scheduling very briefly at the site. Like scheduling is the process of the operating system deciding which process gets resources from the hardware. And GPU scheduling, meaning that the operating system had a bug in distributing the graphics card resources to processors. And this bug led to slight stutters in my video stream. So this is my hypothesis. So I reverted this kernel update. Apparently it is fixed already, but I don't trust I don't trust it now. So I reverted the kernel, and now the video stream today should be not stuttering at all. If so, I mean, slight stutters can always occur, but not this larger one that I was experiencing myself. So just like a real life example, what it means being stable or being bleeding edge. I had a drawback, I had a shortcoming being on the bleeding edge. If you do not, or if you want to have an absolutely rock stable Linux distribution, then you simply do not use a Fedora distribution. Then you would either or rather go with, for example, a Debian distribution. Ubuntu is a little bit in between. Ubuntu is based on Debian, so it's stable by design, but updates packages regularly, but it's not as like on the most recent updates as, for example, a Fedora. That's just a side note. Let me just switch to the slide deck. So last time we talked a lot about files, what a file is, how files are organized. We talked about paths, absolute path, relative paths, and we talked about commands that you can enter in a shell in order to work with files. So we know how to list a directory. We know what is a working directory, how to change a working directory, how to create directories on the file system, how to remove directories on the file system, how to see the contents of files with the concatenate command, how to create empty files with the touch command, and create copies and moving files around with move and copy, whereas the move command has like a double meaning. So you can move a file into a different directory. This is the first line that you see here. And the second use case is you can rename files using move. So if you take a look at the second line here, move file A, file 2.txt, this renames the file that is provided in the first argument here to the name that is specified by the second argument. And as far as my notes are correct, we stopped right there. So we did not do the task files and directories on iLearn. Is my assumption correct? Please answer as a Zoom reaction with a green check mark. And if my assumption is not correct, please do a red cross. Also giving me an indication who's sleeping and who's not. Okay, majority wins. So I assume that my assumption is correct. Okay, so let's take a look at files and directories. And this is like a good entry point. A good entry point for you to, I have it open already, for you to get into the subject matters again. So this is a task on iLearn, files and directories. And the task is to create and move files. So assume that you're tasked with creating a directory structure for the engineering teams on a Linux server. So assume that you're an industry in a team somewhere, and you need to create a directory structure for the engineering team. This structure should include separate directories for both the automotive and the truck project groups. And here are the instructions that you're supposed to do. Create the directory using the structure starting from the temp directory, read a little bit on the temp directory, and proceed with the further bullets. I calculate some time in you taking a look at the slide again, but in a total time of 20 minutes, you should be able to complete the task. And what we are doing as well is we create breakout rooms. So how many people are in the Zoom chat? It's 66 people. Let's do groups of 4 to 5 people because I assume that some people are sleeping and are idling in the chat. So you should at least have 1 or 2 peers that you talk to each other and try to get to the last bullet here. So let me just create the breakout rooms, and hopefully my stream not crashing, because Zoom is always a thing. Breakout rooms, add rooms. Oh, I can let me recreate, recover pre-assigned rooms. What? Save breakout rooms? No. There was a feature where I could like assign automatically. Recreate all rooms? Ah, okay. So how many participants? Let's do 5 to 6. And I will create the room. Please do not join the room. They are not open anyhow. So I created the rooms. The assignment was done automatically, but I give you like a hint how to start. So the directory structure for the engineering team, including separate directories for the automotive and the truck project groups. And you should create the directory structure starting from the temp directory. Let's do or I will show you the first instruction on screen, and then I will open the rooms. You jump in your breakout room and complete all the others. So focus on me for a bit, and I'm switching over to my virtual machine, logging in. I have a shell open. Let me clear that. So my task, the first task is to create the directory structure in the temp directory. So I'm changing to the temp directory using the cd command, and using the make dir directory, I create the engineering directory. I change into the engineering directory and create the automotive directory and the truck directory. And I can verify my work using the ls command, which gives me the contents of my current working directory, which is /temp/engineering. So I successfully created the directory structure, created the engineering directory, and inside that I created the automotive and the truck directory. Okay. So there's a comment in chat. We already one physical space. I cannot take this into account, unfortunately, because the number of participants is quite large. So me assigning everyone manually would last at least 30 minutes. So please adhere to the automatic assignments and join the groups in the respective assignment. So I will assign the room. I will open the rooms. So you should have an assignment. Please join your breakout room and work on the task for 20 minutes. And then we talk again. then sign, this redirects the standard out stream into a file. So whatever output, it's angle bracket. Thank you very much. Let's call it the right way. So this greater than sign is an angle bracket. So this angle bracket is used to redirect the outputs that the history command does into a file. So this is the effect. Technically, what happens behind the curtain is that the history command writes all the outputs to the standard out using basic file reading and writing mechanisms. And you can redirect the standard out such that the contents that is written to standard out appears into this file. Let's check. So the history command, it's just like the history of commands that you put in. But the history command has outputs. And whenever this applies for all processes, for all commands that we use on the command line, the mechanism is always the same. If a process wants to print something on the console, it writes to the standard out stream. A very big key insight of the lecture today. And you can use an angle bracket to redirect this this.txt. You can name it what you like. But what this angle bracket does is it redirects the standard output into a file. So if I hit enter, you see there is no output. Why? Because we redirected the output to be written into a file. If we cat the hist file, you see, well, this is the content of the history, right? Oh, .txt. So we redirected the output of the history into a file. You can do this with echo as well. So hello class, and we redirect this into hist.txt, and we cut the hist.txt. Then we see hello class. So this is how this works. There is a variant as well, because if I change the text that is outputted of the echo command and redirect this into hist.txt, the file hist.txt is written with what exactly comes out of standard out of the process that is running on the left-hand side. If you want to append to a file, you need to do double angle brackets. And if I cat hist.txt again, now I have two lines, right? So if you use a single angle bracket, you basically truncate, delete the contents of the file before you write. If you use double angle brackets, you append what you provide in the standard out of the command on the left-hand side of this double angle bracket to the file history.txt. Can someone think about a use case where this redirecting into a file has a real benefit? I'll tell you. So if you have a process that I mean, writing from one file to another file, this is also possible, right? So if you want to write or append the finishes appended txt. If you want to write the contents of one file to another file, I mean, you could use the copy command, but catting the history.txt, meaning that the content of the hist.txt is written to standard out with this double angle brackets. We redirect standard out to a file that's called appended.txt. If we take a look at appended.txt, well, we have the content right now. If we do it 2 times, if we do it 3 times, if we do it 4 times, and take a look at appended.txt. You see I have 4 copies of the contents of history.txt in the appended file. But this is what I'm not referring to. I'm referring to log outputs. So if a process does some outputs on standard out, or especially on standard error being here especially important because their error messages should appear. And if a process does not what you think it would do, you can redirect like the standard error stream to a file and then take a look what error messages the process has dropped over time. Because these streams, these are volatile. So if you terminate the process, the streams are gone. And if you want to persist the streams, you need to put the content of the streams into a file, because the file is our way how to persist information. So redirecting a standard error stream. So again, this .txt. This is how we redirect the standard out. If we want to redirect standard error, we need to prefix the angle bracket with 2, because 2 is the file descriptor of the standard error stream. And with history 2 angle bracket, let's do error.txt, we do not redirect the standard out. So if I hit enter, I would expect the history output to be shown on the console, because we do not change the standard out stream, but we redirect the standard error stream to error.txt. Let's do exactly that. So we have an output of the history command. There is an error.txt right now. If we cat this error.txt, it's empty because the history command did not have an error. So let me just think real quick. Can we produce an error real quick? Yes, this should be possible. So for example, if we want to copy something and provide garbage as arguments, copy cannot stat, no such file or directory. So if we redirect the standard out into like copy.txt, or let's say copy output.txt, then we still get an output here, because what you see here is not the standard output stream, it's the standard error stream. So the error message was put on the standard error stream instead of the standard output stream. So if I redirect the standard output stream, I need to prefix the angle bracket with 2. I name the error message CP error, and look, I do not get an output on the console because I redirected the standard error stream to the file cperror.txt, and I will cat this, and I have the error message persisted here right away. So this is how the streams work. What you also can do is you can redirect standard out to standard error and vice versa. So in order to redirect the standard output to, or the standard error to the standard output, you do something like this, right? So so for example, let's do this again, right? So here we have the copy command, we have garbage as our parameters. So this will produce an error message, and we redirect like the standard error stream. But we can redirect, I mean, we can redirect to a file. This is what we did before, but we can also redirect to another stream. And this is the &1 syntax here. So what this means is that you redirect the stream with the file descriptor 2, which is the standard error stream, into the stream with file descriptor 1, which is the standard output stream. And this redirects like standard error to standard out. And now if we redirect standard out again in CP output, did this work? Why did this not work? It should, but anyhow, here we redirect the standard output. It's 2/def null. 2, 1. Why does this not work? Anyhow, this should be the syntax of like redirecting. Okay. But redirecting, I guess I had a syntax error here. So what this does, ampersand and then the angle bracket, everything is redirected to standard out. So if I redirect this then to cp output.txt, it's already in standard out, so the second ampersand sign does not make any sense. This redirects all streams into CP output. Now we have it CP output .txt. Now I have the contents of the error stream like in this file here as well. Okay, so recapping, you can redirect standard out to a file. You can append standard out to a file. You can redirect standard error to a file with prefixing the angle bracket with 2. You can redirect both standard out and standard error to a file. Okay, so it's 11:13 right now. Before we go into like the details of streams and 2 more fundamental Linux design principles, let's do a break. And in the break, you think about streams again and try to like make sense out of this, because the next one is a follow-up to what we saw before. But right now, let's do a break of 15 minutes. Is there any question before we go into the break? There is a question, but not related to the subject matters. If it's possible to download Ubuntu in an external hard drive, yes, but please do it as a virtual machine. So you do not need to partition any of your hard drives. You do not need to change anything like on the file system of your computer. Use virtual machines. It's super safe. You can create a safe space in order to have a working environment for this course. Okay, let's do a break and we talk again in 15 minutes. So I hope you had time to like recap and let the information that we just talked about like burn into your brains. So to not to conclude, but to intermediately wrap this up again, look, we have processes, and the inputs of and outputs of processes are done using file-based operations. We have these 3 streams. We have standard in, we have standard error, we have standard out. And if a process wants to output anything on the console here being the blue box, which is a file-based device as well. So in /dev/pts/something, you have the device addresses of this terminal emulator. But anyhow, if a process wants to do outputs, it writes to the file that corresponds to the standard output stream, which is the file with the file descriptor 1. If a process wants to output error messages, it does the same with the file descriptor 2, which corresponds to standard error. And if a process wants to read inputs from the keyboard, it reads the file descriptor 0, which is the standard in stream. And the operating system does all the magic that these streams are established at process launch. And you can do things with this. You can redirect these streams to other streams. You can redirect these streams to files. But now, we talk about fundamental Linux design principles. Two more. These are the last two. But the next design principle is do one thing and do it well. So programs shall perform a single task very well. And we saw that already in the commands that we executed on the terminal emulator. We have a multitude of commands like copy, move, ls, cd, echo, printf, all these commands. And these are programs. I mean, these commands are like programs. And if we enter the name of the program into a terminal emulator, we create an instance of the program in the form of a process. And you see, well, we have small utilities, small programs that perform a single task and do that very well. And we also use text as a universal interface. This is the next Linux design principle, that we use, in fact, not a binary stream in some kind of format that no humans can read and produce, like by heart. Programs use text as inputs and outputs. Like the outputs are text that we can display on the console, and inputs are in the form of text as well, where we can use the keyboard to provide processes with the proper and suitable input that we want. And together with the concept of everything is a file, this leads to the fact that we can chain these programs together and perform more complex tasks by chaining these multiple programs together in order to accomplish greater things. And you cannot imagine how great these things are that you can do with chaining together programs, especially when it comes to text processing. This chainability of programs is a very good tool that you have as a power user and as a programmer, and it allows you to do a lot of things. And the technical tool, how we can chain these programs together, is a pipe. When we define a pipe, we can think about a conduit allowing the flow of data between two processes. And this flow of data, well, let's go a slide back, is basically text, because we have text as input and as output. And if we have a flow of data between two processes, these two processes exchange text together. And technically, we can do this with this bar symbol. And some people refer to this symbol as the pipe. And I'm one of these persons as well. So technically, this symbol is the bar symbol, but we call it the pipe as well. And what the pipe does is it redirects the standard out of one process into the standard in of another process. And you see an example here. Let's do the example on the command line so you see the effects immediately. So our history command again. Let me clear the shell. So our history command again. And you see this is the output of the history command, right? And in the first column here, we have the order of the history that we had in the terminal. But what if I want to reverse the order of the history such that I see the first command in the history as last element of the output? You can do the sort command. Let's take a look at the manual of the sort command. The sort command, again, a utility that does exactly one thing, but this thing very good. It sorts lines of text files. And if we scroll down, we have a multitude of options that we can enable here. But here we have numeric sort, for example. So sort the lines according to a numeric value. And here we have the -r command, which reverses the result of comparisons. This is basically what we want, right? So what we can do in order to change the order of the output of the history command, we can pipe the output, the standard out of the history command, into the standard in of the sort command. This, I guess, has no effect, yeah, because it is already ordered according to a numeric value. But if we want to reverse it, we enable the -n and -r option. And now look, what do I have in the history here? These are the first entries of the history, and it is displayed at the end of the output because we reversed the order of what comes in on the standard output. As an example of how this chaining together can have a beneficial effect. Let's see in a diagram what happened here. So we pipe the output of process A into process B. So this diagram reads from left to right again, and we start with our TTY device, so our terminal or terminal emulator if we emulate this in software. And we have our 3 streams that are connected to this terminal. When we do something like this, so if we pipe the history command into the sort command, the standard in is connected to the first process. This would be our history command. And the pipe does the following. It connects the standard out of process A, so in our example, the history command, to the standard in of process B, to the sort command. So the input of the sort command is the output of the history command. This is what the pipe does. The pipe does not affect standard error. So the standard error of process A, so of our history command, is still going back to the TTY, to our terminal emulator. And process B is executed after process A because, you know, the outputs of process A is pushed as input to process B. And as the input works using the standard in, the output of process A is connected to the standard in of process B. So process B has like the input that comes from standard in, does the thing, like does the resorting, and the standard out of process B of our sort command then is piped back into our terminal and the standard error as well. So standard error is unaffected of the pipe. The pipe works with standard out and standard in, connecting the standard out of process A to the standard in of process B. And you can do a lot of things. So the first use case we saw before with the history, and we reversed the order of the outputs. Here are some other examples that you can use in conjunction with pipes. You can use the let's do less and grep first. So less is a terminal pager and grep is a filter. Let me show you. So you see the output of the history command begins with the number 1108. This story, if I execute the history again, I have 2108. So basically the history is keeping the last 1000 commands. And as each command is illustrated here as a line, the output of the history command is in total 1000 lines. And you see here just the end of it. I mean, you can scroll up, but you need to scroll a lot in order to get to the top of the output. What you can do is you can use the less command, which is a which is a terminal pager, and it's the opposite of more. So it depends on what, like, on if you go from the top or if you go from the bottom. I will show this to you. So if we pipe the history command, history, into less, then we start at the top, and with the arrow keys on the keyboard, arrow keys up and down, we can page through the output of the command, and we start from the top. And we can also use page up and page down, the two keys, in order to do this page-wise. So this is a nice way, a nice and convenient way how to browse through large files, less the terminal pager. If we pipe it into more, it's basically the same. So what's it? Wait, more also starts from the top. How is less than the opposite of more? I cannot figure. This is something that you can ask ChatGPT, or start Googling. Let's ask ChatGPT, because I actually do not know as well. Because the manual says it's the opposite of more, but what is the difference between less and more in context of a bash shell? Yada yada. Yeah, both command line utilities for viewing the contents of a file in like a page away. Ah, it's a joke. I did not understand the joke. Classic German, not understanding jokes. So more was a predecessor of less. So less was developed later as an improved version of more. And the name less is a little bit of a joke, the opposite of more. It offers more features compared to more. So now you have it. It's the successor of more in the tool of being a terminal pager. Okay, thank you, ChatGPT, for clarifying this. So let's use less, because less is the newer version then. And you can like browse, as I said, with the page up, page down, or the arrow keys if you want to do it line by line. You can jump quickly between pages, and if you hit Q, you will exit the terminal pager. So Q is the command for quitting, and you can you go out. The next tool that I guess is one of the most used tools when you use pipes and when you do like text processing on the command line is grep. Grep is a filter, and grep requires an argument. And if you write history, pipe the output to grep ls, grep will discard any lines that do not match the argument here. So if a line does not include the word ls, it's discarded. So as a result, you filter for lines that have ls in it. Let's execute it. So for example, the command 2113, it's the latest command, it's the grep command, but you see these are all the commands that have ls in them. And this is useful, especially with the history, because if you want to have all occurrences of the cut command, for example, you can filter for cut. If you want to have all occurrences for the echo command, you can filter for echo, right? And you can do this with any outputs, because technically what you do is you pipe the output of the history command as the input of the grep command, and grep does then the filtering, and the output of a grep command then is the standard out. You can redirect the standard out of echo again, so you can chain these things together, right? And you can redirect it. You can pipe the output of the echo command into the set command, for example. The set command is a stream editor. and it's primarily used for searching and replacing. So, like out of fun, let's replace in the output of the echo command the echo word to we. Then we do something like this. So this syntax here is search and replace, and it searches for echo and replaces it with we. I mean, the whole expression starts with an S and it ends with a G. The separator here is a /, and if you press enter, you see all the occurrences of echo are now replaced to we. We can pipe this into awk. Next command. Awk is a text processing tool. You can write a PhD thesis about awk because awk is, well, it basically contradicts to the design principle of one tool doing one thing very good, because awk is such a versatile tool that it can do so much and is so complex. And I mean, I use awk for column processing, for example. So you see the output that we have so far. The first column here is like the number of the process, number of the command. Then we have the name of the command, and in the second column, and then we have the argument, the first argument in the third column, and the fourth column we have either, again, some pipes or some further arguments. If we want to filter for example, the first argument, we can write print1. So this is the awk syntax here. And then we get the first column. The second column is with print $2, right? So, and this is the output. But you see what we have done here. So starting from the history command, we filtered for echo, we replaced echo with we, and then we filtered for the column with awk. And we chained this together using the input and output streams this way. And you see, well, you can do a lot of things, a lot of text processing by chaining these commands together. Back to the slide. These are like examples. To wrap it up, less is the terminal pager. You can browse through large outputs by piping to less. You can filter plain text data with grep. And then you have awk as a text processing editor where you can filter for columns. You have sed, the stream editor, where you can do search and replaces. As both awk and sed have many use cases and are versatile, what you need for the XM, so XM relevant statement now, you just need to know these two use cases. So with you need to know awk, it's in scope, but you only need to filter for columns, not for anything else. So you just have to expect questions like, how can I filter a command output by columns? Then you answer with awk, and this is the basic syntax, like print $1. The same for sed. A question can be, how can I replace the output, or how can I replace a word in the output with another word? And then the answer is you do it with sed and the sed syntax. Okay, so these two use cases are in scope. Every other like feature of sed and awk is out of scope, just what you see on the slide here. There's an assignment. Let's do this. So we have an assignment, standard streams on iLearn. Training the work with standard streams. We do redirects because we do not have much time left. We do redirects in class, and redirect and save as well as pipes are meant for homework. So let's take a look at redirects. Use the redirect feature that we discussed before the break to enter text in a file, because so far we could create an empty file, but we could not put text in a file. With redirect, this is possible. So the task is input the renowned quote 7 years ago, which is made from Abraham Lincoln in its famous Gettysburg speech, or also known as Gettysburg Address. And you should input the text 7 years ago into a file named lincoln.txt. And in order to do that, at first you consult the manuals for the cat command. You use the cat command to redirect the output of cat to to redirect the standard in that you provide to cat to standard out, and redirect standard out to lincoln.txt. You terminate it with Control D, and so on and so forth. So you read the instructions and perform the task. We do it in breakouts again, so you can collaborate and you can talk to each other in the breakout rooms. But before there's a question, Ezen, you have a question? Go ahead, please.
Yes, I have a question, and I already asked in the chat about history command. The first time you explained about it, like with greater sign and less sign operators, I didn't understand it completely, and because of that, I didn't understand the rest part of the topics that you just explained.
Okay. This is basically what is the content of the first part. So let's do the following. I will assign you to a breakout room, and like as a first part of this task, you read the lecture slides and try to make sense out of this angle bracket syntax, and then you discuss with your peers in the breakout room in order to get the knowledge. Then you do the task, and if you got the knowledge, everything is fine. Otherwise, I will explain it afterwards again. Are you okay with this approach?
Thank you.
Okay. And then next question from Ene Frank. Go ahead, please.
Yeah, I noticed that when installing Ubuntu in my system, it wasn't really functioning very well. So I performed the last task with this one we're about to do. And then the breakout room, there was not really interactions because we couldn't share the screen. And some guys, the Ubuntu's were not working. So my question is how do we get to reinstall the Ubuntu? Should we meet the school IT system?
Unfortunately, there's like the mic quality is not super good, so I couldn't hear your question. Can you speak loud and clear in the microphone and state it again?
Can you hear me now?
Yeah, a little bit better, yeah.
All right, so what I'm saying is installing Ubuntu in my system is not really functioning very well. So I don't know if it's from my system or should I meet the school and IT section? Because during the breakout section, I couldn't do the first task, and we couldn't share our screens or share our ideas.
Okay, so basically your Ubuntu install was not working, so you struggle with completing the tasks. If this comes up, please notify me pretty early, because we are now like in week 2 or 3, I guess 3. And the task to install Ubuntu was 2 weeks ago, so you have a little bit of delay. And please make sure that you come to the lectures prepared in a sense that you are technically prepared and also content-wise prepared, such that you understood everything from the last section, because they They build up consecutively. So what I will recommend to you is going over the descriptions here in the task as well, and thoroughly follow the guidelines that are in this task Ubuntu virtual machine. If this does not work out, please write me an email. Maybe there is a quick fix that I can help you with. Otherwise, the next best thing that you can fall back to if you're using Windows, you can use the Windows subsystem for Linux, which is a way how to install a Linux kernel and a bash shell on Windows using WSL. But still, the recommended way is to use a virtual machine, because we will have tasks where the WSL is not sufficient enough. And as a very last resort, but I don't know if this is applicable for everyone, there are like online bash shells as well. So the online bash compiler, for example, where you can put in commands and execute these commands on a shell as well. But I guess that most of the tasks that we are doing are not doable in this kind of online bash compiler. So please, as a first or target for getting the virtual machine up and running, if this does not work out for like it does not work out at all, try to install WSL with Windows. What you can also do is you can go to like if you're in Germany and if you're in Deggendorf, maybe you can catch a computer in one of the computer rooms that have Linux installed. This is also a way. But again, try to get the Ubuntu virtual machine up and running.
Right, thank you.
Okay, so where was I? Standard streams. So this is the task. For the task, I give you 15 minutes, and I will do the breakout rooms again. So let me check if these breakout rooms work. Here we have them. I will recreate all the rooms. Maybe you are assigned a different room right now, and assignment is done, and open all rooms up now. So please join your room, and we talk to each other in 15 minutes again.